Are you guys back?
Yep.
Okay, so two things. One thing is I upload two calculation working sheet to the D2L. So the last two, one is a calculation, another one is actually a sheet to tell you, to teach you how to do this calculation. So they go through step-by-step way to tell you how to figure out what you're gonna calculate. So this is from an instructor before. He gave me that. It's pretty good. You can check that out. And another one is a calculation working sheet. It's a kind of like a multiple calculation things in there. So you can go through the first one to learn how to do it. Then the second one will be a practice sheet. So lots of practice question down there. That's one thing. Second thing is I saw there's a few people to worry about. They said, "Oh, Jack, let me see what they said down here." They said, just give me a second. Go too fast." Said, "We have to go to module 7 before Friday. And do we have time? And exams on Friday." So whoever's here, the exam, you will have 50 questions, right? I told you. You have a 10 question. It came from module 1. You have 19 questions came from module 2. So that's 29 questions. And module 3, you will have about 5 questions. It's talking about pressure, those things. Module 4, it's talking about flow meter. You only have 3 questions. Module 5, it's a temperature sensor. You will have about 7 questions. And the module 6 is talking about the control, general control idea. You only have 2 questions. Module 7, the final actuator, the final control element, you only have 4 questions. So the majority of the questions came from module 1 and module 2. And like I told you at the beginning, this in the automation course, we want you to understand the basic. So later on, later module talking about a lot of flow meter, temperature sensor. Temperature sensor is easy to understand, but the flow meter, pressure meter, those actuator, different kind of valves, those things. We just going to give you a kind of introduction to let you know some basic. We're not going to ask you to understand, to remember all the detail in those things. Okay, so that's why total for this automatic controls, we start on Friday afternoon, half day. Yesterday, Monday afternoon, half day. Today, tomorrow, and Thursday. We have a total 4 days. If I can finish section 2 today, which is half of the time, we're going to cover about 29 questions. It's more than half the question. That shouldn't be bad, right? So if we finish it today, section 2, tomorrow we probably can finish it section 3, section 4, get into section 5. And Thursday morning, we'll finish everything. Then the Thursday afternoon, probably I'm just gonna be answer your question if you have any of the question. So don't worry about the progress we have here. And I'm not gonna say, okay, I don't have time to finish the last few modules. You're gonna read them yourself. It's not that gonna be that case. Okay, so just calm down. We're gonna go through everything nicely, and we're only gonna test you on the basic thing. The basic thing is in module 1 and module 2. That makes sense? Yeah, I know some of you think, oh, we only had module 2. Friday we have the exam. How do we have the time to finish all those? Don't worry about it. Okay. Okay. Before lunch, we were talking about how we calculated the percentage. So the percentage down here, they kind of tell you how to calculate. It's if you measure at X milliamps, the X milliamps subtract 4 over 20 subtract 4 times 100%. That's going to give you a percentage. And you can also confirm those in here. So that's different percentage. That's the amps, that's the volts, that's pressure. And you can do a practice on here. You're probably going to be showing you the right answer down there. So you could have some question. They're going to say, oh, it's the output at how many percent? Then what's the actually the current is, or if the input is at what percentage, then what gonna be the input, either the pressure, the temperature, the whatever the value you're gonna use. Is that okay? I guess you probably have to give a try yourself, then you will understand those things. It's not that hard. And also, there is a bunch of, I believe some of you have been tried the quiz. So the quiz on module 2, they will have a bunch of calculation in there. And your exam now gonna be harder than those quizzes questions. So if you can do the quiz question, you should be able to do the exam question. There might be something I have to give you a little bit here. Let's see. So this is a pretty simple example. It said it's a 10.4 milliamps. What percent of the measure is this reading? So 10.4 milliamps, subtract 4, divide by the total range is 60 milliamps, give you 40%. That's good. Yes? No?
Sorry, can you just hold that page for 1 second if you don't mind?
Yeah.
Thanks.
And also you have this on the D2L as a PDF file, I believe.
Okay, well then you don't have to keep it. I won't hold anyone. I'll just look at it later. It's all good.
No, it's okay. If you usually like you don't have to, you could take a screenshot and if you want, you can write down, right? But most of the time, what I try to say is you don't need to write down if it's on the PDF, on the PowerPoint, because it's usually on the PDF file in there.
I just took a picture. That's all I needed to do. That's great.
That's good. Yeah.
Okay. Thank you.
No problem. Just let me know if you want to take a picture or anything. You said, yeah, hold on that page. I will let you.
Okay. Thank you.
Yeah. Okay. So the percentage calculation is pretty simple. If I give you a percentage, can you find out the current? Let's say I have a 60% of the output. How many milliamps is there? Yes, no? What took you guys so long? 12? Yeah, 13.6. That's the right answer. So first, what's the span down here? 16 milliamps, right? 16 milliamps times 60%. Give you 9.6. 9.6, you're going to add that 4 on top. So 13.6. If you get this question wrong, come to BCIT. I can ask you to come to my house. Okay, joking. Okay, now let's do this question. A process being measured at 72% of its range, the signal produced by a transmitter have 4 to 20 milliamp output. Which one gonna be the right answer? So let's see. 15.52. Good. So that's pretty good. Hey, Milan, now you get the right answer. Are you still worried? This is easy. Yeah. Everything related to calculation is easy. Okay. So on the D2L, there's a working sheet, there's a quiz question. You guys can try those. Yeah, the PowerPoint is on D2L. If you go to, I believe it is, are you guys paying attention in my class? That's the one thing I kind of have to worry now. So that's on the D2L. That's the PowerPoint down here. Really? Go there, take a look. Tristan, if I found this slide, you didn't find it, you know someone gonna be in big trouble. Someone gonna getting hurt really bad. Okay, I think you are right. I think they updated the PowerPoint before they put in there. So yeah, I know you are a good student. Just try to scare you a little bit, but didn't success. Those are smaller things, right? And did you guys want to take a picture? So this one and this one, you can take a picture if you're kind of worried about. Yeah, these two wasn't in the Okay, now the next one we're gonna talking about is accuracy and the errors. The accuracy is talking about the limit the output might deviate with the true value. Usually, the accuracy is the percentage of the whole span. I believe when you're in year one, you guys learned something about meters accuracy, right? The meters accuracy, let's say if your meter is 2% accuracy, and the meter is used to measure from 0 to 200 volts, and if you have a reading about, let's say 50 volts, what will be the possible true value of that reading? You guys did those type of questions in year one. I don't know if you still remember or not. So the accuracy is based on the whole span. So if it's 200 volts, you have 2%. So 2% times 200 volts give you 4 volts. Even your reading is 50 volts. So the possible value there will be 50 plus 4 or 50 subtract 4. So the actually reading will be from 46 to 54 volts. It's the same thing here. Actually, the span, the accuracy, maximum deviation from the actual value over the theoretic span. In here is the maximum value. So if you have an accuracy of 0.5%, your input is from 0 to 100 kilopascal, and you could be have a 0.5% of that 100. So 0.5% of 100 give you 0.5 kPa, and your reading could be add that or subtract that. For your output, for the current, it also have that accuracy. So the span will be 16 because it's 20 subtract 4. 16 milliamps times 0.5%. Your reading will be adding 0.08 milliamps or subtract 0.08 milliamps. So that where we can find the maximum reading and the minimum reading when you read a value down there. Here we give you how much you can go over, how much you can go low. So that's the accuracy of the transducer, the same as what you learned before as the meter. There is the other type of errors. The error is because all those transducer or equipment, they might have something to causing, like ideally, we want to get every time we use a transducer, we can get 100% correct reading, but in the real world, that's never going to happen, right? We know in the real world, there's always going to be some error, some variation in there. So there's a 4 common type of error going to connect with the transducer. Usually, the more expensive one you buy them, the less error you're going to have. If you want to save money, and the more error could be in there. First is a 0 error. So in here, they give you an example down here. You're supposed to output a 4 to 20 milliamps output, but actually your real output is from 8 to 24 milliamps. So that's just have an actual 4 milliamp in there to causing your reading shift down there. in the real world, you expect to get 4 to 20, but when you're actually doing the things, you either have to do a calibration to make sure that the 4 milliamp is disappeared, so your reading is between 4 to 20, or for some of the transducer, you cannot do the calibration. You just have to take in the 8 milliamp as your minimum value and the 24 milliamp as your maximum value. So that's they call the BIOS. It's actually called the BIOS. The typing here is the error. We call the BIOS error. It's called the zero error. Span error. Span error, another name they call the gain error. So your starting point is right. Your minimum value give you 4 milliamps, but when they go up, you're supposed to only go to 20 milliamp, but the actual output can reach 24 milliamps. So those error, because it's cross the whole span of this transducer. So those one are called a span error. You don't need to worry about how to calculate this span error. So the calculation before we talk about those things, that you have to know. Those one is just for your information only. Do I go through one page too fast? Oh, I'm missing one. Okay, maybe on the next page. Okay, I'm missing one. So in the book, on page 2-18, they also talking about another error called linearity error. So for a transducer, your input and output, they should have a linear relationship. But because everything when they build them, they have all different kind of components in there. Something can affect them, temperature, humidity, all those things will affect actually the output. So you can say the actually output is not a straight line anymore. It's actually like a curved line around there. So your output is not linear anymore. Those are called a linearity error. That could be existing in lots of transducer, almost like all the transducer might experience those type of problem. And for those type of problem is sometimes it's the installation, sometimes it's the location, sometimes it may be the wire. Yeah, you're not going to calculate for accuracy or for those. Yes. For you guys, if you remember there's 4 different type of error, that's good enough. You don't even need to know how they occurred, because nobody actually knows for those things why they occur and how they occur. But it's actually existing when you go working in the real world. Those type of error is there. If you can know the name, that's already good enough. You don't know the name, I don't think it will hurt you at all. And also another thing is, do you have an open book exam? So if I ask you a question, I said, what's the 4 or 2, which is the transducer's errors? You can find them in the book. That's already good enough, right? So another one is called a hysteresis error, or they call it the dead band, is when you're using a transducer to measure certain thing, when you measure them from the lower value to the higher value, and when you measure them from the higher value, go to the lower value, they actually give you different values. So if you ask me why it happens, can't tell you. Some of them depends on how they made, how they created. Maybe they have a, let's say if you have a temperature sensor, when you try to measure the temperature going up, and when you try to measure the temperature going down right away, maybe the sensor's terminal temperature have not go down to cool down yet. So you try to measure them, they will causing this type of error in there. But you have to look at each detail component, try to figure that one out. And there's no way, no general way you can say why this type of error happens. So in the book, there's a common wording they call it, you can control whatever, you can control to the accuracy you can measure. So those transducers, especially the sensor, the input transducer, if they cannot measure really accurately, your system control is also going to be affected by those errors. That's good enough. You're never going to do the calculation or anything. That's just a very general reason they give to you. But for each device, each transducer, if you really want to know, you have to actually taking each case individually. Repeatability is when you're measuring those transducer, they might not be always give you the consistent output for the certain. Let's say you try to, let's say a pressure, right? You have a 20 psi pressure. You use the same transducer. You measure today, measure tomorrow, measure the day after tomorrow, or measure next week. If it's a good one, they probably always give you the same output, but sometimes depends on lots of things. The measure might vary. So you're not going to get in the same reading all the time. That's the repeatability. For the smart and the intelligent transmitter and the digital communication, you can read them by yourself if you want actual information. We're not going to test you anything on there. So, and another way I was trying to think is the year 4 apprentice course will lead you into different aspects of this trade. If later on you get into this aspect, you probably have to spend extra time and effort to learn it. You're not going to be just through the 2 or 3 week course on year 4. You can become an expert in that respect. Okay, so next one, we're going to, let me think. So because some of the questions for your quiz or those things, it's actually require you to understand optical encoder and the linear variable transformer. And so we're going to talking about this optical encoder, and we're going to talking about that LVDTs. first, I'm gonna try to show you another. So this is the different program. We go through this one, then I will tell you the optical encoder in your book. It's also give you a little bit of very short, simple explanation down there. So optical encoder, it's usually an electrical mechanical device that provide feedback information in a closed loop motion control system. Let's say we're talking about a step motor, right? We can send in a signal to the step motor. We ask the motor to turn, either to driving a conveyor belt or just driving some rotational equipment. But how do we know if the step motor turning to the degree or turning at wherever we want it to turn? So we could use an optical encoder to read that feedback. So if this just a step motor as the actuator is turning and we want it to turn at a certain speed or turning at a certain degree, then we can use an optical encoder as our measurement device to give back the signal to compare a comparator to control the signal sent to the step motor to say, okay, now you can stop or you have to turn in a little bit more. So this is a rotational, this is a linear movement. It's one type of DC motor. We can do the rotational measurement, circulation, or linear movement. Direction, position, and velocity. So we will talk about how it can give us those informations. So it will tell you the motor is rotating counterclockwise or clockwise, or you're turning to the left or turning to the right. The position, it can tell you if it's a rotationally, you can separate into different degrees, and they will tell in which degree this rotor moved or how much it moved in the linear direction. I think this one have a problem for this page. Don't worry about it. The optical encoder is they have a light source. The encoder have 4 major elements: light source, light sensor, optical disc, and the signal conditional circuit. So here the source gonna emitting a light, the sensor gonna try to receive the light, and this disc is usually mounted on the motor shaft or mounted on anywhere. The disc is have some cutout and have some blank out the area. So when the light can go through the cutout, the sensor receive the lights, they will receive a pulse. If its lights got a block out, the sensor will not receiving anything. That's how they work. And the signal conditioning just receive this light sensor, give out a pulse signal. Then the signal conditioning circuit gonna try to convert it into a standardized, useful form signal to, let's say, maybe 4 to 20 milliamps, might be 0 to 10 volts, or whatever the standard signal we can use. Okay, I'm gonna repeating the function of this signal conditional circuit or signal conditioning unit in the sensor. Doesn't matter if you have a transmitter, you have a transducer. The signal conditional circuit, the function is you're gonna converting this input signal from whatever the sensor gave to a standardized or usable form. So it can be used by a different device. Okay for that? So that's important to know what's the function of the signal conditioning circuit. My voice loud enough to wake you up. So the signal conditional circuitry or signal conditioning unit in any type of the transmitter or transducer is to converting whatever the input signal to a useful or standard the signal for for the instrument or for the equipment downstream. So the light source, light is usually a LED. The infrared lights is commonly used because if the visible lights, they might get distorted or they will have some kind of bad effect on human also. Light sensor usually is a photo transistor, or you can have a photodiode, photo SCR, doesn't matter. It's sensitive to infrared energy. So this one sending out the lights, this one receive the lights. The infrared lights also have a good thing is it's not gonna be affected by if you turn on a normal lights or lamp in the house, in the room, or you turn off the lights. We don't want any extra things to causing problem. The optical disc here is between this sensor and the source. So they connect on the same shaft as those motors, and they have those cut out the opening, and they have covered area. So when this one turn to certain location, the lights can go through the cutout, and when they turn to next location, it probably got black out by the covered area. So you can see here, when the shaft is rotating, the sensor will receive the lights in a pulse. Because certain time the lights can go through, certain time the lights is blocked. Now the receiver side, here's the signal condition. The receiver received the signal down here is the photo transistor, and they have some kind of triggering circuit down here. You don't really need to know this part too much, but we try to show you what type of the signal you can receive down here. So when you have a light go through there, when the light is going to this photo transistor's base, when the base have a current, they will choosing photo transistor can be fully saturated. So that little bit of current, we causing this photo transistor fully saturated. When this saturated, the voltage between the collector and the emitter will be really low, and your power source down here will be have a voltage drop across this load resistor, and because this triggering circuit is connected onto the collector of this transistor, when when the input to this triggering is 0 volts, the output is 0 volts. So the output will be this signal conditioning just because you might be have a, let's say the lights got blocked a little bit, or you have a delay in this action down here. When this voltage is now totally 0, if without this triggering circuit, this way more like a waveform the output, but we want to totally either the output gonna be a square wave, either 0 volts or either 5 volts. That's the purpose for those triggering circuits. That's why we call the signal conditional circuit. So next part, when the light is blocked, so there's no base current into the phototransistor. The phototransistor is totally turned off. When this one turned off, the 5 volts, there's no current flow. The 5 volts will drop across this collector and the emitter to make the trigger, the input circuit to the trigger, to stay at 5 volts. This triggering circuit is kind of just like a follower. So when the input is 5 volts, the output will be also 5 volts. So you can see here, when this rotating, you sometimes you have a input light sensor, sometimes you don't. The collector waveform will now be a standard square waveform. So your collector might have some kind of curve for the rising edge, for the trailing edge, but go through this triggering circuit, you will have a perfect square waveform output. Okay, now let's do some questions. Be good. So you paid attention. When light striking the photo transistor of an optical encoder, A, resistance is low, near 0 volt potential at the collector, output near 0 volts, of above. Which one will be the right answer? Yeah, Taylor, have confidence in yourself. D is the right answer. So same thing for the exam. You will have those type of question. I think you will have a few of the question. Actually, the answer is all of above. Okay, it's not very common in the exam you've been writing so far before, like in year 1, year 2, year 3. You're barely gonna have an answer all of above, but in year 4, this automatic controls, you will have a few answers all of above. But you still have to know them. When light from the light source is blocked, and how many volts cross? Okay, read the question. How many volts gonna cross the load resistor? Yes, 5. Oops, sorry. Hold on a second. When light is blocked, so this one is not, yeah, 0 volts. Click on the wrong one. Haha, you guys start laughing at me. Because when this is blocked, so there's no volt, no current through, the load resistor going to receive 0 volts. the function of optical encoder trigger is to converting which one? That's for sure is A. Okay, so we finished this one. The optical encoder is actually on the book in your module. It's at module 5. On my book is 5-27. They talking about this optical encoder, and it's about 1 page, 2 page, almost like 3 pages. So in here, we're talking about it can tell you the speed because the speed will be how many pulses it come out. But the rotation, the direction of rotation is they using two channels. So they could, depends how they set up. They could use 2 light sensor, 2 light source, or they using 1 light sensor, have a 2 sensor inside, then 1 lighting source. So the 2 channel, they are putting one on top of another one, and those cutout and the blocked area is a shift a little bit. So by reading the signals, because only the cutout will give you a high voltage output, and the blocked area will give you a 0 volt output down there. By reading between channel A and the channel B, so which one reached the high voltage first, which one reached the high voltage later, they will know the direction of the rotation. And also they can know another way is they can use they call the gray code. I believe it's on your book. They talking about in 5-29. There is a so this is another one. They using actually is a gray code down here, and you can see there's a 4 light sensor goes through, and the 4 lights depends on different location. It will be the receiver will receive a different type of like a coded signal down there, so they will know the exactly location of this disk rotated. It's an electromechanical device. Monitor the direction of rotation, position, and the speed of the rotation or linear. They have 4 components in there. We already talking about what each component does, and what's the function of this signal condition unit? Anyone? No one? No one's paying attention in my class. Everyone's falling asleep. My class is so boring. Yeah, so it could be converting into a standard signal or converting into useful signal. Good. So Wilson is a good guy. Eric is a good guy. Huh. Maybe I should give the guy whoever answered the question some bonus mark. Yeah, the rest of you guys, you just don't want to talk to me. Why you hate me so much? A variable frequency driver. The variable frequency driver, I think some of you have been learning VFD in year 3, but I believe since the pandemic, you guys didn't have a chance to do the lab in there. The VFD, the control signal, usually you can give a 0. In our BCIT's lab, you give a 0 to 10 volts DC input. You can control the output frequency of these VFDs. So for the VFD control, there are 2 different ways to control them. One way is you have this, should we say, directly proportional. So you start with 0 volts and start with 0 hertz. You reach 10 volts, you reach maximum frequency, let's say 60 hertz. Another one is inversely proportional control, is you're using 0 volts at 60 hertz, and you're using 10 volts at 0 hertz. So, you know, they will give you totally different answers. Yeah, we better do a question like that. So make sure you guys are able to do these questions. So VFD doesn't matter. Let's say 0 to 10 volts, control 0 to 60 hertz. My input is at let's say 7 volts. Find the output frequency is equal to quick. You got 3 seconds to do this question. If you can't do it in 3 seconds, someone gonna getting hurt. Yes, 42 hertz. Sorry, I shouldn't push you, right? But you could using the formula we're talking about before. So you go with 60 subtract 0 over 10 subtract 0 times 7 subtract 0 plus 0 give you 42 hertz. But you totally could encounter a different question. A VFD using 0 to 10 volts versus 60 hertz to 0. So now the 0 is equal to, we give you 60 hertz, and the 10 volts, we give you 0 hertz. Let's say my input is at 7 volts. Can you find out what going to be the frequency at? So two ways we can figure this one out. If we put in the formula, we consider this is the minimum value, maximum value. We put it the same way down there, 0 subtract 60 over 10 subtract 0, 7 subtract 0. But now this is our 0 value. Add a 60 on there. That will give us 18 hertz. Make sense? Or another way, you really don't like this, right? You said, yeah, I don't like the negative number. It caused me problem. But okay, here you got to pay attention. Okay, you will encounter one of the question like this. Look at these two number. What that two number give to you? They add up equal to 60, right? So if you count one of the question like this, and you don't really want to use this way to do it, you can use that way to do it. Once you get that number, use 60 to subtract it. I don't know which one working for you. I just gave you a suggestion. Yes, no, good, not good. So two ways you can use this way. It's still using the same formula. It will work. Another way is if you saw this one is backwards with the one before, you can calculate that number, use 60 subtract it. Transponder working this way also. Transponder, which transponder are you talking about, David? David Henry? And sorry, I didn't fully understand your question. They will tell you. They will tell you if for 0 to 10 volts is controlling the output 0 to 60 hertz, or they will say 0 to 10 volts, output will be 60 hertz to 0. Opposite relationship with the input and the output.
Yeah, because you were, sorry.
Yeah, go ahead.
It was just because you can have the same negative relationship if you started with like say a 0 to whatever 4 to 16 millivolts, and then have your output be like we were going from low output to high output, but it could be high output to low output too, right?
Yes.
Okay.
Yeah, if that's what you mean, that's right. Yeah.
Yeah.
So you will encounter one of the question is one side going to be go down, not like the one we did a lot of go up, right? You will have one go down. Today is June the 1st at 12:30 p.m. I showed you this. If you're not able to do this, you come to me. Don't say I never told you this. Okay. What do you guys think? You want to take a coffee break or you want me to keep going? Coffee? Okay, we take a 15-minute coffee break. We come back at 12:46. See you guys later. Hey, are you guys back?
Yep.
Okay. I think Nathan asked me a question, and he sent me in private. You don't have to. You can just ask me. I think you bring up a very good question. So I like to show you guys this one because this is a pretty, I would say, common type of question. So you guys can see this, right? It's he taking this question from one of the quiz. This question, why they make this way is they try to make things looks complicated, but actually the thing is not so complicated. So they try to write a bunch of wording in there, try to confuse you, and let's see how we can simplify this. So the words are really long. Following signal-to-signal conversion, the output from the valve should be how many liters per minute. So that's what we want to find is the liter per minute, right? He said a pressure signal is 10.5 psi, measured on 3 to 15 psi positioner for operator actuator of a control valve. The electrical signal to the position is a milliamp signal, standard 4 to 20 milliamp. The positioner convert milliamp signal to pneumatic signal. The data stored in 10-bit address. The valve is normally closed. Fail to close. I'm not sharing the screen with you guys. You can see it. So, okay, I stop it. I share again. You should see everything because I try to share this screen. Then they said when the valve is normally closed, fail to close. When closed, the flow rate is 0 per minute. Fully open, the flow rate is 212 liters per minute. The valve is linear, 50% actuator with around 15% change. On the current loop, current to voltage transducer convert the current signal to a standard 0 to 10 volts range, transmitter to a flow indicator recorder. Please use answer, use 2 decimal point. So for all those things down here, we could draw a full picture of this thing. But to draw in the full picture, we need to understand the whole process. We need to understand the whole thing down here, right? Do we have to do that? I don't think so. The important wording down here, so I'm going to try to highlight it. The important wording is pressure signal 10.5 so that's some important wording. Pressure signal is 10.5 psi, 3 to 15 psi positioner, and flowing rate is from 0 to 212. Why I think the flowing rate is important? Because they want us to find out the valve should be how many liters per minute. All the rest of those, if you guys excuse my language, I will say all the rest of them is BS. All bullshit. We don't care. Sorry, my language. Who said to report me? Eric Davis? So, said use this pressure 3 to 15 psi to operate the control valve. And the valve close, it's normally closed, fail close. So normally closed will be 3 psi. When you fully open, will be 15 psi. It's related to 212 liter. And they tell you it's linear. And the linear here, you think it's important, you think it's not important. Let me tell you, all the question you're gonna do, it's gonna be linear. If not linear, we're not gonna ask you to do it. That makes sense? Oh, you guys want me give Davis, Eric Davis, a 0, a fail? Give him a version F test? Okay, that would be a good consideration. So now we know 3 to 15 psi. The pressure is 10.5 psi. 0 to 212 liter per minute. We want to find out the flow rate. Okay, Jacqueline's idea is pretty good. We now give him 0. We give him a low mark. So I can do this is 212 subtract 0 over 15 subtract 3. 10.5 subtract 3 plus 0. So I got the value 132.5 liter per minute. The one I gave to you on the D2L, they will do this. They do 10.5 subtract 3 over 15 subtract 3. They try to put whatever the thing you want to compare together. Then this 212 subtract 0 plus 0. They should give you the same value. Yeah, it's the way they try to think. If they only give you 2 value, like a input and output to a transducer or transmitter, they think it's too easy. That's why they put in a lot of those wording down there. There's no real meaning in this question. So you will encounter the question. The question on the hub. Oh, excuse me. Just give me a second. Sorry, I have to sneeze. Yeah, it's inside a practice question, but also you're probably gonna see a type of those type of question on your exam. They give you lots of those useless information to try to tell you how you can find them. Tristan, when you say other way around, is I didn't get what do you mean other way around. Yes, no. Tristan, what's your question? Other way around. What do you mean other way around? Sorry, I didn't get that part. PSI was over, like these two, you mean? Yeah, doesn't matter which way you do them. So this is the formula, I think, in the book. It's also the formula on the D2 on the PowerPoint. So the book and the PowerPoint use this one, but it doesn't matter this one on top or that one on top. This is the one of the working sheet. The working sheet, they tell you, you compare your pressure to the pressure, or you compare to flow rate to the flow rate. You can find the pressure. Okay, so if you encounter those type of questions, will you be able to handle it? I want to hear some yes. Good question, Nathan. Maybe. What's this? Yeah, I think, yeah, you can post it. We can do that, no problem. Yeah, when I actually come to his home, I'm gonna bring my 3/4 inch EMT binder. Use the handle for that. Oh no, he's Caucasian, so I can't do that. I can only punish Asian student, because Asian student, they usually get punished by their parents when they are young. Okay. I'm gonna copy and paste. So here is the second question. Move this one to next page. Okay, now it's better. Okay, so here the second question. Signal to signal conversion, the binary number stored in the following indicator recorder register should be what binary number? So this is talking about binary number, right? So that's more like this morning we're talking about. A pressure signal of 10 psi measured on 3 to 15. So one thing is you need to find out first thing, what's the value they give to you. So this one have the value, that should be the one we consider about. Control valve, electrical signal to position milliamp, 4 to 20 milliamp, don't care. The position convert the milliamp signal to numeric value. The data storage is 10 bit. So that's also another thing we care about. The valve normally closed, fail to open. When closed, is 0 liter per minute, fully open, the 150 liter per minute. Valve the linear, blah, blah. Also on the current loop, current to voltage transducer, convert the current signal to standard, and the transmitter to follow indicating recorder. So from here, we know the 3 psi going to, because it's a normal close, if we close it, and when 15 psi, we cause it to open. So this is kind of important, but it's not very important. We can choose a different color. So because this one might be give us, we have to go, it depends on we go directly proportional or inversely proportional. But I don't think we're gonna try to trick you using this type of question because already lots of information down here. So now you guys can see this. I highlighted the important thing. The rest of the stuff, we don't really care. So pressure. Pressure is 10 psi. The range is 3 to 15 psi. Register is 10 bit. 10 bit, so the total number is from, we know 2 to the power of 10 is 1024. So the register's range is actually from 0 to 1023 because 0 gonna occupy 1, and the maximum number, if you have a 10-bit register, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the minimum number will be 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Give us a 0. The maximum number will be that, give us 1023. Now, all we have to do is for this, we can go. We want to find out the value, the data stored in 10-bit register. Do they ask for decimal or do they ask for binary?
Binary, Jack.
Binary? Okay, that's fine. So we can do first thing. We find that the decimal number gonna store it down there. It's going to be, let's see, the number is going to be 1023 subtract 0 over 15 subtract 3, then 10 subtract 3 plus 0. That would be the decimal number. So 12 times 7. So the number is 596.75. But for the binary, they cannot store a decimal number, right? So this number will be 597. For this 597, your calculator, so your calculator, you cannot directly convert this number to decimal. If you're directly converting, you're going to give you an error because you don't have enough digit. There's a lot of different way you can do it. I think Milan already gave me the answer. One way to do it is I can convert this number into octal, or I can convert this into hex number. So I convert to a hex number is 255 hex. Then from the hex to the binary is every number you're gonna convert to a 4-digit. So 5 to binary gonna be 0101. 2 convert to binary gonna be 0010. So first one is 2. The first 2, I don't really need it. I can go 10. Second 5 is going to be 0101. Third 5, 0101. That's one way to do it. Second way, you always have a computer, right? I will have a computer. And your computer, we have a calculator function. So here's your computer's calculator. You choose the programmable calculator. You put a 597 down there. Then you want to go to, they show you the binary number down here. Easy cheesy. So we get. So those type of question is they just try to give you a bunch of information that have no relevance to your final calculation or whatever. All you need to do is filter out how I'm filtered those information out, because they gave me a pressure value. So the pressure is the value I'm going to use. The next one is what they want me to find. They want me to find what's in the register, the binary number. So I need to find out, okay, how many bits that register is. Other than that, I don't care. 4 to 20 milliamp, 0 to 10 volts, 0 to 150 liter. You can call those information whatever you want to call it. But if I say it, and I think David tried to report me, and I'm going to take someone's suggestion, give him a test, he can only get 32%. the 255 is if you don't have a computer, right? You have a decimal number 597. You cannot use the calculator to do the conversion. So you can, the H means it's a hex decimal number. Okay, so we already did this question, like VFDs, and we choose the same value down here. So next one, we're going to talking about, we call the linear variable differential transformer. This linear variable differential transformer, they also talking a little bit. It's on the book. I'm not sure if you have the same book. On my book is also on module 5. Module 5, page 26. We call the linear variable differential transformer. Because there's some question on module 2, that's why we're gonna cover it in here. Same thing, I can show you in another program first. LVDT. Some call linear voltage differential transformer, some call linear variable differential transformer, but they are the same thing. They work in the same way. It's a device. They produce a variable AC voltage to represent the physical position of the object connect to. They usually have a core, because transformer, we know the core going to causing to increase the flux density. They can increase the permeability. They can have a better building a better transformer, right? And those things, usually they have one primary coil and they have two secondary coil. The layout of them is the core is a ferromagnetic material for sure. Usually it's soft iron. The soft iron will improve the flux line or improve the flux density. So between the primary and the secondary coil, they can, here is the basic of a transformer. So primary coil, you got a voltage, you have a core, they will induce a voltage on the secondary coil. That's your transformer. You learned in second year. But this LVDT, they put a two secondary coil in there. So here the important thing. Here the how the secondary two coil connect together. They have two windings. They actually is reversely connect them together. So when the core is in the center, which will induce equal amount of voltage on both secondary coil. When they connect, you can see they didn't have the marking down here. Usually they, maybe next page they will have the marking. Here the H1, here's your X1 here, here's your X1 on the secondary coil. So you actually connect the secondary coil in reverse. So in here you can see they induce a voltage down here, and both of the secondary coil, when the core is right in the center, they both induce 2 volts on the secondary coil. But because the secondary coil is wired together backwards, the output from this terminal will be 0 volts. That's where they try to show you with a DC circuit. So if the core go to the top, so that's where the core is attaching to where the movement is. The core move to the top, so the top one will have more stronger flux density or have more stronger field. They're gonna induce more voltage down there. The bottom become air between here, so they're gonna induce less voltage. The output will become positive 2 volts because this is wired backwards. That's how it works. And if the core is moving to the bottom, now you're gonna read a negative 2 volts down there. So that's how they know how much this core moved, so they can deciding the position of this. And because we know the input is AC in here, your output also AC, depends on this core movement. You will have a polarity in phase with, if it's on top, it's in phase with the primary waveform. If at the bottom, the waveform will be 180 degree out phase with the primary side. Make sense? Okay, 2 secondary coil of LVDT are series A or B? B, good. Opposing because they wired backwards. The voltage at the secondary indicating if a core is located above or below the center position. So you're using the voltage value or using the phase value to indicating the location of the core. So like we showed you, if on top, it's in phase with the primary side. If at the bottom, the 180 degree out phase with the primary side. When the core of LVDT located above the center position, the AC waveform at the secondary is, we're already talking about, in phase with the primary. And what's gonna tell you how far the cord moved? That's the voltage value gonna tell you how far the core moved, right? The phase just gonna tell you it's above the center or below the center. Okay, so we have some basic idea about this now. Third question. Oh, I closed it. It's okay. I can open it. I'm gonna go faster. So here's the third question. Okay. You're welcome. Gonna try to explain that again. Here is usually how the linear variable voltage differential transformer look like. They have a connection down here, and this is attaching to wherever the thing is moving, like this part. No displacement, you got 0 volts. Large displacement, you have more voltage. Smaller displacement, you have a smaller voltage. One is moving, if the voltage output is like this, you are moving above on the coil 1. If your output voltage like that, you're moving to the bottom. The magnitude is indicating the distance the core from the center position. The phase above the center position, the voltage is in the same phase. When it's below the center position, the 180-degree out phase, or I don't think there's a proper word called opposite phase. Here is actually some picture of where I mentioned to you, Alan. He working in that brewery, beer brewery. Here's the controlling system. They got a bunch of sensor, a bunch of controller, those kind of industrial control application. And he have this is a display on the computer for the controller, and they have those real tanks, the sensors mount on the tank, and those meters. Those are flow meters, and this is another type of meter. I can't see clearly. And I think they have those is the sensor for the liquid level inside, and they have some kind of sensor on the floor. It's actually the strain gauge they can use to okay. The last question from here is what going to be the answer? D, 40%. Good job. So that will be the end of the second module 2. I also want to mention something. It's in under D2L, you have a certain document. It's in module 2. So if you go to the content, one thing they're talking about is read switch. This read switch is very common in security system. So if you install a security system in your home, let's say the window or the doors, they usually we have those read switch. So if the doors open or the windows open, they will send in a signal to the security panel to make a notification or make alarm state. The simple operation principle is they actually using some magnet, either permanent magnet. They usually use permanent magnet. So when the two magnets connect together, they complete the circuit. They thinking the door or window is closed. But if you somehow open them, the magnet is not touching together. They will corresponding to open. They will tell you the door is open or the windows open. So those are how those read switch works. Then here they give you more explanation. If you like, you can read through them to get some basic understanding. Another one is this called okay, whenever I say this name, people gonna laugh at me. So anyone? Ifan, can you say this word for me, please? He's still in my class. Or Milan, do you want to say it loud so everyone can hear you? I say it, people gonna laugh at me. Okay, so now gonna say this name. I call it a tachometer.
Tachometer, tachometer,
Tachometer. Okay, thank you.
tachometer,
Oh, thank you. Because when I say it, people say, you want to order taco? Just make fun of me. So this is for measuring the rotation speed. If you've been, I don't know, you guys, how many of you guys been in the school for third year? If you've been doing the DC machine or AC machine lab, you're gonna sometime you use that. But if you never did, you probably never use it. So how how they're gonna use them to measure it is they actually the principle is a relative motion between the magnetic field and the shaft of coupled device. So they actually working like when the shaft is rotating, they're gonna generate a voltage down there. So they just based on the generated voltage, they can converting that generated voltage into the speed of rotation. So that's why they call that DC tachometer generator, or maybe another one is called AC tachometer generator. So the working principle is they use rotating magnetic field to generate a voltage, and it depends on the rotating speed. The generated voltage will be different than converting that voltage into the rotation speed. So there's some extra thing you need to know. Yes, no? Also, I got someone sent me an email. I think it's Jess Gale. Jess Gale, are you in the class right now? Yes, okay. So starting from this January, all the fourth year become the harmonized fourth year. Even you didn't take any harmonized course before, it doesn't matter. The only change down here is before you learn VFDs, in harmonized you learn VFD in year 3, but in non-harmonized you learn VFD in year 4. So we're gonna offer some those we call the bridge class later on. So someone gonna teach you bridge class. There will be VFDs, there will be HVAC, there will be something concerning little bit about the code. I believe for the some code relate to either the transformer or something. So those they call the bridging course or whatever the course just bring you up to the harmonized class. Those course we don't have the exam, but they just going to give you, I believe, VFDs for 2 days, 3 hours each. HVAC maybe 2 days, 3 hours each, or the code maybe 1 day for 3 hours or something. So later on, they're gonna offer those courses to help you to catch up. So no worry about if you haven't taken the harmonized class before. Before the IP, I think they're going to offer last term. We offered starting in either week 5, 6, 7. So before the IP, we will offer those gap training or whatever the course. Yeah. But there's no exam come with it, so it's optional for you to attend. And if you kind of like a VFDs, there might be some question on IP. HVAC, there usually question on IP. So it's good for you to know a little bit about it. Anything else? Let me think. Okay. We're gonna talking about slightly a little bit more later on, like what's the final control element. in module 7. But if I give you a bunch of device or a bunch of transducer, that's a proper name, right? Transducer could be RTD, could be string gauge, could be a semester, could be pressure sensor, could be a flow meter, could be a relay, a motor, a heater, anything else, a contactor, sonic level detector. So a list of the transducer down there, we'll be able to figure out which one is a sensor, which one is let's say final control element, or the common words we call the actuator. So RTD is what? Hello? Anyone still there? Can you guys still hear me? Or everyone falling asleep? Yeah, we said all those we could be considered a transducer. But I want you to separate them into two categories. One category is the sensor. Another category may be the actuator. So this is the sensor, right? That's good. What about strain gauge? Can you use a strain gauge to driving anything, or you just use strain gauge to measuring something? That's the difference, right? So strain gauge is a sensor because it can tell you if you have a weight on top, you will change the resistance. So thermistor is also a temperature measuring sensor. The pressure sensor, they already tell you is a sensor. The flow meter, is you using this meter to measuring something, or you use it to control something? If it's measuring, it's a sensor. What about the relay? is using for control, so it's actuator. What about a motor? It's actuator because you're using it to control something. What about a heater? It's an actuator because you can generate heat through it. Contactor. It's an actuator because you can close the contact to complete the circuit to drive in something. Ultrasound level detector. It's a sensor. Good. So I know we haven't covered all of those sensors we're talking about in next few modules. We're gonna have a bunch of sensor or transducer covered down there, but transducer is a really broad range, right? You, as long as you're converting one form to another form, so transducer, you could be input, could be output, and it could be sensor, could be anything. But each individual instrument in there, you need to be able to identify it's either a sensor or it's actually an actuator. If you're using the instrument to do measurement, it's a sensor. If you're using the instrument or device to control something, it's an actuator. So a very common actuator would be control valves. That's going to be in module 7. They have a different kind of valves, but how much do you need to know? We only have a 4 question in there. We can test you all different kind of control valves, how they work, and where you're using them. We're just going to give you some basic idea. I think we're going to leaving for now. I think we're pretty good because even we only cover 2 modules, but we almost covered about 60% of the exam material. The update PPT, I could just convert it and upload down there. I don't think there's too much difference in there, but yeah, sure, I can do that. Okay, I will do it right now. Okay, give me a second. Save as PDF. Okay, and I think I finished converting. I can upload down there. Okay, gonna delete the old one first. So yeah, okay, it's done. So the new PDF is up there. Let me open it to see it's actually updated. Oh, it's still loading. Yeah, so it's up there. Should be good. Encoder practice question. No, I don't think so. I don't think you need to worry too much about the encoder. You might have some question on the quiz. So online quiz might ask you something. I think that's why someone asked me this morning about the encoder. Yeah, that's just about it. Do you want to have the encoder question on your exam? I don't think I'm gonna test it on there. No. Yeah. Okay. Okay, so control action and control classification. You mean module 1? Those things. So you mean those things, right? Either we call the direct action or reverse action. I wouldn't worry too much about that because even for the textbook, they didn't give you too detailed explanation about the direct action, reverse action, and they just mentioned something is it's a more look like it's more related to if you want to control something, right? So make a simple examples. If you have a temperature control for your building house temperatures, you set the temperature at let's say 20 degree or 22 degree, and when it's summer, so your arrow signal reading from the temperature thermostat will be higher than the set the temperature. So if you want to use air condition, the more temperature you read down there, you're gonna turning on the air condition in full power or more power into the air condition. But if the temperature is lower than your setting, so you get a negative reading down there. When the arrow signal will be negative, then if you try to heat your house, the more negative arrow you're reading between your setting and the temperature, then you will go turn on the heat in full string, or you turn on the heat in smaller action. So those are kind of things relate to direct action or reverse action. That's the control action. But mostly the control is when we're talking about later module, you will know we have something down there. We want to keep the process or anything close to there. You don't even need to know the examples. You're never going to be asked it's direct action or reverse action. If I didn't tell you, it's important to know. You don't need to worry about too much. Even for the book, they just gave you 2 sentences, like those sentences. They couldn't give you too much example or explain what's that. So it's, sometimes when people writing a book or whatever, and they just they have to cover lots of things, but sometime and when something they covered, it's not inside the process and the motion control, you need to know some basic, like the batch control, batch process or something, continuous process. Those are the things you need to know. But for those direct action, reverse action, don't worry about it. And the same thing for classification of the control system. It's just how you try to identify something. So the basic example I can tell you, I'm not sure if appropriate or not. Let's say you have a screwdriver. The general term, the screwdriver is the tool, right? But you can also call it's an electrician's tools. And the electrician, you use a plier, you use a cutter, you use a screwdriver. You said, okay, it's a belong to maybe also belong to electrician's hand tools, and also belong to electrician's screwdriver tools, because you might have all different type of screwdriver. So those are how they talking about classify the control system. Like I said, as long as you can identify the closed loop and the open loop control, that's good enough. To base on application, a Phillips screwdriver, you can say, oh, it's a electrician's tools, or it's a plumber's tools, or it's a any tradesman's tools. And if you're using this Phillips screwdriver, you said it's a hand tools, and that just the different those type. It's basically it's how people want to call them. Motion is different. I think the process. I think a process control have 2 parts. One is a batch process. One is a continuous process. You're making cookies. That's batch process. You're making paper or garbage bag. That's continuous process. So the difference is you putting ingredient together, you mix them, you wait, like a cookie, you have to wait to rise, you have to bake them. So you cannot do something like making cookie when you're putting the ingredient down there and then you continuous have the cookie come out. So you have to mix certain amount of ingredients together to mix them together, to make the doughs, to move them through the oven, to bake them, come out. It's not like you're making paper, a garbage bag, you put the original material, something in there, they go through the whole process, they came out continuously. The motion is different. Motion is totally like if you want to moving a crane move how far, or if you have a conveyor belt to moving something, those are the motion. Or if you want to the motor to turning, the motion control is more like later on we're going to talking about wind turbine generator. So the wind turbine generator, the blade, you have a pitch control. That will be you're turning the angle to make that motion. Yeah, motion control is always related to you move something, and the process is like you try to make something, build something, or produce something. Yeah, it's more like those. Okay, guys, I think today finally I saw 49 people down here, and for the last 2 days, sometime I saw 43, sometime I saw 47. So finally we have someone join our class. I'm not taking attendance, so you just have to catch up whatever you're missing. It's 2 o'clock. If you don't have any question, and you can, I think I will open more quiz for you. So if you read ahead, you can do the quiz ahead. But if you didn't read ahead, you can, at least now you can do all the quiz in module 1 and 2. I will open more quiz. So you know your exam gonna be Friday afternoon, right? No, not afternoon. Your exam gonna be on Friday. You can starting at 11:29, and you have to do before 12 o'clock. If you're after 12, you're not gonna be able to get into the exam anymore. So I leave the half-hour window down there. It's a 50 question. You have 2 hours to do it. And if you come to my class, you pay attention in my class, you should you should be get a pretty decent mark. The book is it's a good thing, but like you said, you can't buy the book. So because I explain things one way, my PowerPoint or explain things in one way, the book might show you a different way or give you a different example. But if you can borrow one book from someone, at least I believe read once. Because through the class we try to cover certain thing, and we might miss something. So it's better to have a book reading all the modules. It will be helpful, but I think as long as you come to my class, if you pay attention, you follow everything, you do the online quizzes, you probably still will be able to pass this. No problem. Okay. Anyone have any other question? Calculation only up to the amplifier, what we need to know. Yeah, I'm not going to ask you to calculate the accuracy and the errors. So basically, all your calculation is a module 2 to converting the input, output, percentage, data register, number. Yes. Yeah, no calculation on accuracy and errors. Don't need to know those. Or if I give you a version F exam, like I think, who's the guy try to say he's going to report me? Oh, then everything will be a fair game. Even the thing I didn't cover in the class, it's on the book, it's on the D2L, it's on the handout or anywhere for him. That Eric Davis, that's the guy trying to report me. Oh, I already forgot the guy's name. So maybe I will let him go easy this time. If you have a question, that's another thing I always tell my student. If you have something you couldn't figure out, just bring to the class tomorrow. Email me. I might not check the email, so. Like during my working hour, I will try to answer all your questions. But when I finish my working hour, I need to take some rest, right? Oh, you guys are student. You want to pass year 4, so you're working extra hard. I heard some of you guys never sleep. You're working whole night. Decimal to binary? Use the computer. That's the most easy way. Yes, I'm not lying. Or one way you can do is with your calculator. But your calculator, I believe, cannot go more than, oops. So 511, let's see, you can go to, yeah. So on your calculator, if you have the same calculator like me, you can only go to 511 from decimal to binary. Once you go over, if you go to 512, you cannot go anymore. So use the calculator on the computer will be the best thing. And you guys all have a smartphone. Your smartphone can do that also. Let me see. What if I want I haven't figured out my smartphone too much for the calculator. No, I never heard anyone said you have to do the conversion on the IP. Most people told me, myself, what I did is 100 questions on the IP. I used the calculator less than 5 times. And most people told me there is a really less than 10 to 15 questions you actually have to do the calculations. Lots of them is code, and now it's troubleshooting and or trade knowledge. Yeah. Yeah, they're not gonna ask you to converting decimal number to a binary or something. Okay, 211. Should we end the meeting now? Yeah, those are IP practice questions. Even it's not like you're gonna say the exactly the same question, but a lot of familiar same question. So those are also a good good question to try them out. Okay, so any specific question relate to module 1 and 2? Oh, you're welcome. If not, I will see you guys tomorrow morning. Tomorrow we're probably gonna go through 3, 4, get into 5, maybe finish the majority of 5. Then Thursday morning we're probably gonna do finish 5 and 6, 7. Then oh, you're welcome. I like you guys. I know lots of you from the year before, saw your name. I think, that's my student before. And whenever you guys know my ruler, you're probably my student before, right? Sorry to say that. Yeah, I'm a mean Asian, the worst instructor in BCIT here. They haven't fired me yet, so I'm lucky. I'm famous. I hope you heard the good thing about me, not the bad thing about me. Okay, I will end the meeting and see you guys tomorrow. Oh, okay, good. Thanks. Okay, see you guys.